So don't talk, just act. Don't say, just show. And don't promise, just prove. So, with this quote, we will begin our today's session. Now, today's session and the sessions from onwards are very interesting, and these are related to your, we can say, chemistry knowledge. If you have sound chemistry knowledge, then this topic will be easier for you. Okay, now this is application oriented part, and this is related to very important part of the phytoconstituents. So today we will discuss a topic, structural elucidation of the natural products. Now, what is a structural elucidation? That is the question. And it is the process of determining the chemical structure of a compound. It is called as a structural elucidation. So, the process by which we can determine the structure of compound, it is called as a structural elucidation. Now, these structural elucidation have various processes like the physical processes, analytical methods, chromatographic methods, and spectroscopic method. Now, these methods, I have not mentioned here the chemical methods because those are not mentioned in your syllabus. So, we are going to discuss few methods which are available in your syllabus. So, one of them is a physical methods like melting point, boiling point, optical rotation, refractive index. Now we can say these physicals or physical methods are physical constants also. Okay, so these melting point, boiling point, optical rotation, refractive index. Then apart from that, the others, uh, we can say physical methods are also available, like checking the solubility. So these physical methods actually, uh, even the ash value, it is included in the physical method. Extractive value, it is also a part of the physical methods. Okay, so all these methods are described in the physical method, and these are the physical constant. For example, ash value is a physical constant of any herbal drug, therefore it is considered as a important physical method in determination of the structure. Okay, now the next one is a chromatographic methods. Now, chromatographic methods. Now, here I have mentioned only the constant derived from the TLC or HPTLC. But we know that the chromatographic techniques, those are the separating technique. We separate two constituents from each other, and it will help to determine the structure. It will help to separate the different constituents which are present, and in case of TLC, RF values are considered as a constant. So those values are helpful in determining the structure. Then HPTLC, like the fingerprinting is there in the HPTLC. So that part is also important in the determination of the structure. Apart from that, these chromatographic techniques are in association with the various spectroscopic methods like the LCMS, GCMS, or other hyphenated techniques. Those are also available. Okay, so these techniques like the chromatographic methods, those will help in the determining the chemical structure of a compound. So for example, TLC, HPTLC, it will give the constant, and those constants are helping out in a determination of the structure. Okay, then analytical methods. So analytical methods like the composition, determination, and combustion analysis. Okay, now analytical methods are also helpful in the determination. Today we will discuss one method, that is a determination of the elemental composition. It is normally done by the atomic absorption spectroscopy. This part, I think it is there in your analysis syllabus, but this elemental composition we will study today. Determination of the combustion analysis, how it will be helpful in determination of chemical structure, we are going to discuss. in forthcoming lectures. Then the last part, that is a spectroscopic method. Spectroscopic method like the UV, IR, proton NMR, and mass spectroscopy. So with the help of electromagnetic radiation and a certain wavelengths, we will able to determine the structure of a particular compound, and these methods are generally considered as an electromagnetic uh, spectroscopic method. Okay, so those methods are very important in terms of herbal drugs structure determination, and we are going to discuss that in this syllabus, that is a structural determination of the herbal drugs. Now the physical methods. Now let us begin with the physical method. Now these methods are simple methods and we are all aware about the physical method. So let us have overlook about that. That is a melting point. So melting point. Melting point, it is the temperature at which solid melts to become a liquid. Okay, it is the temperature at which solid melts to become a liquid, and the transition between the solid and the liquid is so sharp for small samples of a pure substance that melting points can be measured to 0.1 degree centigrade. Few examples are mentioned here, like the beeswax, uh, 63 degree centigrade, carnauba wax, candelia wax, ucuba butter, etc. So these melting points are constant and those will help us in the determination of the structure. Then boiling point of a particular compound. So the boiling point of the substance is the temperature at which vapor pressure of a liquid equals the pressure surrounding the liquid and the liquid changes into a vapor. So that is a boiling point. Now on this screen you will see essential oils and their boiling points in degree centigrade and degree Fahrenheit. So various essential oils have a high melting boiling points, high or middle boiling points, and low. Okay, so depending upon their boiling points, we can identify them. It will help us to identify the structure of the particular compound. Like the anise oil having very high boiling point, like 232 degrees centigrade. Caraway oil having a middle range boiling point like 212 degrees centigrade. Cedarwood oil, clove oil, then fennel oil. Those are having high level of the boiling point, while lemon oil and eucalyptus oil is having a low level of the boiling point. Okay, so that is about the melting point and the boiling point. Now next is a optical rotation. Now the optical rotation is the angle through which the plane of the polarization is rotated when polarized light passes through a layer of the liquid. So optical rotation is nothing but the angle through which the plane of the polarization is rotated when polarized light passes through a layer of the liquid. Now, what is the optical activity? It is the ability of a compound to rotate the plane of the polarized light. And a compound is said to be optically active when the linearity polarized light is being rotated when it is passing through it, and the optical rotation is the angle through which the plane of the polarization is rotated when polarized light passes through a layer of a liquid. Okay, and optical rotation is the effect which is determined by the concentration of chiral molecule and their molecular structure in a specific substance, and every active substance has its own specific rotation. So optical rotation normally is given, or it is a property of chiral molecule and their molecular structures. Okay, and the compound which is optically active when the linearity light is being rotated, when it is passing through it, the optical rotation is the angle through which the plane of the polarization is rotated. So the angle, how much is the light is rotated, that angle is generally considered as a optical rotation. Now, optically active substances again classified into two types, like the dextrorotatory, levorotatory. Dextro, the substances that rotate the plane of polarization of light towards the right, and those who uh, rotate light towards the left are known as a levorotatory. And a specific rotation of a liquid is the angle of rotation. Okay, it is an angle of the rotation. This is important part. It is a angle in which the polarized light rotated. Okay, so for example, straight line, polarized light is going, but if it is passing through a particular compound, that light is rotated either left side or the right side, and that angle is considered as a specific optical rotation. Okay, now the optical rotation, this is the formula which is given on your screen. There you can see a solvent must be coated when you are determining the optical rotation. So there the specific rotation alpha, uh, the temperature you have to mention, and then D, that is a wavelength of the monochromatic light. Okay, that is uh, measure at a 589 nanometers, is equal to, that is a specific rotation is equal to A upon LC. Okay, so where A is observed rotation and L is the length of a sample tube, decimeter, and C is concentration. Now in our college we are using this, you can say, digital polar optical rotation determination. Okay, a digital polarimeter. Okay, so that digital polarimeter have two types of the tubes in which we can place a sample. So that decimeter changes. So therefore calculation, while calculating you have to mention the length of that sample tube, then concentration of the sample, and observed rotation, that is a. So this is a formula to determine the specific rotation. I think this is covered. This is covered in your syllabus during the practicals. I hope that is covered. Then next, that is the optical rotation examples. So on your screen you will see a melting point and specific rotation in given solvent. Okay, like the minus 15 or 40 or 39.6, it is mentioned in. Okay, these are the specific rotations which are given. So these specific rotations are there. So these rotations will give the angle, like minus 15, that means which is levorotatory and dextrorotatory, right rotation positive. So plus plus minus. Okay, then the next method is a refractive index method. Refractive index of a material is dimensionless number that describe how fast light travels through the material, and it is calculated by n is equal to c upon v, where the c is the speed of light in vacuum and v is the phase velocity of a light in a medium. Increasing refractive index corresponds to decreasing speed of light in the material. Okay, increasing refractive index corresponds to a decreasing speed of light in the material. For example, if refractive index is 1, that means the speed of light will be, we can say, constant. But if it is 1.33, then that speed of light speed of light decreases. Okay, so refractive index, for example, the water, it is 1.33, that is a refractive index. So if a particular light passes through that with a certain speed, okay, for example, speed of light in vacuum and the phase velocity of the light in the medium. Okay, so when it is passing through a water and water's refractive index is 1.33, that means it will slower or decreases the speed of light. And if take example, certain fixed oil are having a refractive index around 1.45, 1.5, or even more, that means the speed of light get affected, get decreased in case of these. Okay, and those compounds whose refractive index is less, for example, say for example 1.22, 1.01, so those compounds will have a better speed of the light than compared to the water if it is below 1.33. Okay, now see, examples are given on your screen, like lemon oil 1.474 to 1.476, then lavender oil 1.459. Okay, that means lemon oil 1.47 is decreasing the speed of light as compared to the water. Okay,